Okay, thanks, Dave. Can everybody see the presentation? Can everybody hear me okay?
Yeah.
Yes, Carl.
Okay, great stuff. Yeah, so thanks for inviting me along, Dave. I'm Carl Baker. I'm a fellow of the Permanent Way Institute. I've been in railway engineering for 32 years now. Started at British Rail Area Civil Engineers. Area Civil Engineers covered North Wales and Mid Wales, where this particular timber trestle is. So I have some experience of this type of work very early on in my career, although during a reorganisation in the early 90s, the Crewe area lost North Wales and Mid Wales when we became intercity engineers, which was a bit of a disappointment for me, but managed to get back on the North Wales area working with Amco Giffin the last couple of years. They've got a framework contract for structural renewals and refurbishment in the whole of Wales and Western, as is now. So involved with various schemes in Wales, and Traeth Mawr timber trestle was one of the highlights. So we'll move straight into the presentation then. So I'll tell you a little bit about the background and history of the area and the structure and why that's important. Tell you the scope of the project, a little bit about design. I'll talk about access and environment, because that was probably the most important thing about the scheme, particularly the flooding that we experienced on the site. So I'll tell you about the construction and how we refurbished this structure working in an estuary environment, and I'll tell you a little bit about how we commissioned it and completed it, and some of the challenges that we had around that. Okay, so there's a photograph of the timber Trestle Viaduct in question across the River Glaslyn, just outside Porthmadog. It is a floodplain. That's the river when it's nice and calm and lovely to work on. I'll come on to describe what it looks like when it's a little bit angrier, and I've got some photographs to give you an idea of how challenging it was. As Traeth Mawr, roughly translated, it means big sands. So it's a floodplain just outside Porthmadog. So just to kind of orient us all geographically, so just outside Porthmadog in North Wales, the bridge is Bridge 83 on the Dovey Junction to Pwllheli line, 118 miles 40 chains, so it's between the stations of Minford and Porthmadog. The River Glaslyn, which is really important, obviously runs down from the Snowdonian Range from Aberglaslyn down through various settlements, other rivers joining it, and then it flows into what originally was an estuary into the river, into the sea at Porthmadog. But then the Maddocks, William Maddocks, the Maddocks family, who were important people in the area in the early 19th century, involved with quarrying and mines. They were instrumental in developing the area of Porthmadog, and they built a cob across the estuary between Minford and Porthmadog to allow the settlement to develop and to get a harbour in Porthmadog, and then eventually a road and a railway were built on top of the cob, which is now the A497. It's got the Festiniog Railway on top of it now, and the road, and then the railway came along a little bit later in the red dotted line there. Okay. So a little bit of history of the railway itself, and the viaduct was originally part of the Aberystwyth and Welsh Coast Railway, opened around 1867 to Pwllheli. Benjamin Piercy and Henry Conybeare were the engineers who designed most of the timber trestle viaducts in North Wales. Barmouth Viaduct being one of them, one of the more bigger and famous ones. Thomas Savin was the contractor who built the viaduct. He was from Oswestry. I think you can visit his grave in Oswestry, I think. But the viaduct was originally a lot bigger than it is now. It was originally 40 spans, so it was a huge. It was probably, we're down to about a third of the, getting on for a third of the original size. Over the years, the structure has been modified. It's full of different types of timber, softwoods like pitch pine and Douglas fir, and then more recently, the likes of British Rail and Railtrack and Network Rail started to do the refurbishments of the timbers with harder woods like Eckie and Greenheart. And I'll come on to that in a bit. And you'll see from some of the archive drawings and photographs that the embankments and abutments were brought forward to make a much smaller structure than was originally built. So over the years, it went from 40 spans, being rebuilt in 1914 to 21 spans, and then I think around 1930 it was reduced further to its current 16 spans. There's a 1899 Ordnance Survey map which shows the River Glaslyn in the middle and the timber trestle viaduct going over the top of the floodplain and the river itself. This was when it was 40 spans. So this is the western side to Porthmadog, the eastern side on the right to Minford, and you can see that the original embankments only went up to just right of where it says side of bridge. The abutments are much closer to the riverbanks now. The eastern side abutment never moved, but the western side was where the spans were reduced. There's a photograph from 1893 that shows Snowdon in the background, the Snowdonian Range, the mountains there, and then you've got the estuary, Traeth Mawr in front, with the original 40-span viaduct there, which has been reduced to its current 16 spans. There's an archive drawing from Cambrian Railways. This was the archive drawing of the actual, when it was reduced from 40 spans to 20 spans. And you can see that in dotted lines, parts of the viaduct which were removed. And you can also see crosses between some of the other piers, trestles of the bridge, where they built intermediate trestles to remove the old trestles. That's how it was built to its current configuration. And there's a photograph showing that the original piles are still in situ in mid-span of the slightly newer structure from about the 1920s. So those are the original piles of the trestle driven into the riverbed in remarkable condition for their age. And I'll come on to that a little bit later about actually the structure under the water and in the riverbed fares much better than it does out of the water. So we'll come on to that in a bit. There's the current arrangement. So you've got Minford on the right, Porthmadog on the left. You've got a concrete abutment on the east side with wing walls. You've got just a concrete abutment on the west abutment. And then you've got 15 trestles and 16 spans. Okay. So the contracted project scope for AMCO to deliver the scheme for Network Rail was a replacement of a number of timber structural members. That included the piles, the crossheads, corbels and edge beams. And I'll walk you through some drawings to explain what those different elements are, the corbels and the edge beams. AMCO giving that to replace all the associated metallic fixings that were associated with those structural elements. That's bolts and straps. I'll show you some photographs and drawings of those. We replaced the handrail in its entirety. There wasn't any track work as part of this scheme, but we did have to jack the way beams up as part of the deck jacking to enable us to get access to replace certain members and the actual deck boards. Okay. So The scope of the project was to refurbish the structure because it was suffering from certain types of distress and defects and decay. You can see there a photograph of a diagonal member where it adjoins with a pile. You can see the rot and the decay in the timber there around the area of the join with the main member. There's a couple of piles which were earmarked for replacement. So again, you can see how severely decayed the timber is, especially around the water mark. That seems to be an area of where the defects can occur. These are photographs of the timber outside of the water line, well above the water line, and again you can see probably softwood members have rotted and decayed significantly around the bolt and strap areas. Quite a lot of rot and decay there, obviously affecting the integrity of the structure. For the scheme to sort of turn into a design from the inspection and the scoping, so these structures are unique to North Wales. There's probably 6 or 7 sites of timber trestles in the North Wales area, most of them on the Dovey Junction to Pwllheli line. They're inspected visually every year, and detailed examinations are carried out every 5 years, and that's where they obviously build up the scope of the decay to the timber members. So obviously this structure reached a point where it was felt that an intervention was required to ensure the integrity of the structure and keeping the railway open. Cass Haywood, working with Network Rail, developed the design by surveying the structure first with point cloud, and then from that point cloud a wireframe model was extracted. You can see that on the slide, and from that wireframe model we were able to build up a series of elevations and cross sections, and then mark up on those drawings which elements were to be replaced, and then from those drawings we were able to order materials and start planning the refurbishment works. That's a cross section through one of the timber trestles, and there's a photograph next to it to give you an idea. So I'll just walk you through the definitions of the components of the structure from the top to the bottom. So obviously you've got the track system on top with way beams, so they're long timbers. So beneath the way beams you've got the deck itself and the supporting beams, which go across the railway, across the spans between the trestles, and then below the supporting beams you've got the crosshead and the trestle. To the side, either side, you've got edge beams and corbels. So you've got the edge beams at the top and the middle, then you've got the corbel, which is a timber element which sits over the top of the crosshead. The trestle itself, there are 5 piles to each trestle. You've got wailings at the bottom, and you've got diagonals which brace it all together. The majority of the spans were in this configuration, apart from 5 in the middle of the structure in the deepest part of the river. In the deepest part of the river you have the same timber trestle arrangement, but you've actually got outriggers and outrigger wailings outside of the main trestle to give it additional stability in the deeper river sections. Okay, some photographs on top of the structure before we started work. You can see there in the middle the way beams with transoms and tie bars in the middle. There was a bullhead check rail on the outside of the bullhead track system, check rail to keep the trains on. You can see that it's fairly old. Certainly, I observed some base plates from the 1930s, Great Western base plates on the track system. So, you know, the bridge and parts of the bridge have been there for a very long time, although it has had many interventions over the years. So some of the elements were a bit newer, but you can see that the handrail there is in poor condition, timber upstands and steel handrails, very, very poor condition. This is the schedule of elements and components of the structure that we had to replace. So there were 32 edge beams to replace. There's 50 edge beam corbels. We were packing the main beams, although we didn't have any main beam. We didn't change any main beams as part of this work. There was some packing and shimming of some of the main beam corbels as well. We had one crosshead to replace. We had 7 piles to replace. We had one diagonal whaling to replace. We had 3 outrigger diagonals to replace, 5 horizontal whalings, and then we had the sort of the straps and the bolts to replace as well as the handrails. The whole of the handrail system was changed with a FRP system, and then there's some deck plank works to deliver as well. So this is an extract from the design drawings. You can see in red, typical cross section of this one's Trestle 9 in the middle of the structure, where we had 2 piles to replace. That to be spliced onto the existing piles in the riverbed. We had an outrigger to replace, 2 edge beams, and all the associated bolts and straps with those elements of the work. So this was replicated over almost every single trestle. This type of different bits being changed on each trestle. As part of the works, we identified that there was some temporary works required to enable us to get access for some of the replacements. This was probably the biggest piece of temporary works. It was a maybe system of jacks, beams and columns, which enable us to jack up part of the structure to enable us to change one of the crossheads. You can see the design drawing there and the actual delivery on site, photograph of the system installed, which enabled us to jack up part of the structure to enable us to change the crosshead. It was quite challenging in some respects because we weren't able to jack off any softwood elements of the bridge, so we had to make sure that this system only jacked off bits of the structure which were a bit newer and hardwood, and it also created some no-go areas for sort of plant and some of the giga cranes working on top of the structure as well. So we had some exclusion areas during certain parts of the programme, which I'll come on to in a bit. Some other pieces of parts of temporary works were some props which were installed during some of the pile replacements. You can see on the drawing, the cross section on the left, that prop was installed during changing one of the piles on the outside of the structure, just to make sure that we maintain the integrity of the structure. I'll tell you a little bit about the timber specification. Majority of the new timber elements we were installing were green heart. It's a hardwood that comes from Guyana in South America. It's a D70 grade structure, D70 grade timber, which is incredibly durable, and it's perfect for these estuary and marine environments. It's heavily resistant to insect attacks. I don't know whether anybody on this presentation knows about what happened to Barmouth Viaduct in the 1980s, which nearly closed the line. It was it got a marine boring grub got into the timbers, into some of the softwood timbers, and required, major works to Barmouth Viaduct. Now we're using the likes of Greenheart and Eckie. There's much less chance of those critters like that being able to bore into the timber and causes a major problem. Whilst the timber is magnificent for its durability, it makes it very, very hard to work, and particularly to sort of work and shape and change on site. The timber is so incredibly dense and hard that when you see chainsaws on it, you can see the sparks coming off the chainsaw. It is that hard, and it's very heavy. So 1,000 kilograms per meter cubed. Some of the timbers, some of the members were over 3 tons to lift in. We also used a very similar timber to Greenheart from West Africa, a timber called Eckie. We used that for the shimming and the packing and some of the deck boards. It's very similar material to the Greenheart. Okay, so I'll now talk about some of the logistical issues we had working in the estuary environment of the River Glaslyn. It's a floodplain. It's also tidal. There's various triple SIs and other nature conservation areas around it, which prevented certain things that we could do. We obviously had issues with working at height, with it being a viaduct over the river. We had to get a gas main removed from the structure to allow us access. Luckily, the gas main was redundant, but it took us several weeks to establish whether it was redundant or not, and the utility company couldn't even tell us. Working over, on and in the water, and I'll come on to that in a bit. Incredibly difficult conditions on site, so we used divers, and I'll describe that later in the presentation. Just telling you a little bit more about the Afon Glaslyn environment, nature reserves, Ramsar sites, triple SIs, you name it, we've got it in that area. So we had to work very, very carefully. Luckily, there were existing access roads to the viaduct. However, one of them was completely unusable during most of the project because it was underwater. So the majority of access came from the east. We were hoping to use access from the west, but as you can see from that cross-hatching, most of it was underwater. So that's one of the flood maps. The viaduct is in the middle of that darker blue line in the middle. You can see the flooding to the east all the way up to Porthmadog. Not so far on the west side, but still caused us problems. Unfortunately, when the scheme was tendered and most of the planning was done, this was before my time on the project. Unfortunately, one of the pre-construction maps which was sent over to Amco Giffin had an error on it, which didn't show the full extent of the flooding. So unfortunately, a bit of naivety. We tried to deliver the scheme we originally planned the scheme to be done from scaffolding, when in reality we couldn't use scaffolding due to the amount of flooding that we experienced. Why does the area flood so much and so badly? Well, I talked to you about the Maddox family building the cob, and you can see the cob at the top of the photograph that the Welsh Highland and Festiniog railways run on. And also they built these floodgates, tidal gates, where the River Glaslyn flows through to the harbour, Porthmadog Harbour to the top right. In fact, these floodgates were put in to protect the harbour, because during high floods and high water levels, the flow rate is incredible and travels through the harbour at great speed. So these tidal gates were installed to protect the harbour and stop it getting washed away. But that kind of just pushes the problem upstream and kind of created a bit of a problem for us on our job, to the point where it's kind of, because you've got the tide and you've got floods and you've got the gates all to take into consideration on trying to understand what the water does at the actual viaduct. So we had to engage a local consultant who did some river modelling for us and came up with some predicted tide ranges, the flow rates through the structure, and the sort of times to expect that. And again, this was all a little bit last minute, and that's because we'd been sent this map which was incorrect. And with the scheme being planned in the summer, and people visiting site, you think, oh, it's not that bad. Can't think it's going to be that bad, but in the reality in winter, it's a completely different environment. So we got this modelling done to enable us to sort of effectively plan what activities could be done in or out of the water. And again, it was a bit last minute, and we had to get sort of, at the last minute, we had to plan more activities to be done by the likes of divers working submerged rather than guys on scaffolding, because we couldn't install the scaffolding in the end. These are some of the outputs from the river modelling that we got. So this gives us the velocity of the water, the speed of the water in meters per second as it flows through. Their averages, obviously it can vary across the bed of the river. Sometimes where the water is more shallow, it can actually travel a lot faster than the deeper parts of the river in the middle. And we also obviously got the tidal range, about 3.5 meters that the tidal range was, 3.5, 4 meters through the structure. Again, that caused us issues, the pontoons that we worked from eventually going up and down. And obviously the flow rate governed when the divers could actually work in the river, because if the flow rate got too fast, then it would be unsafe for the divers to work in the water. I think they can work up to about 2 meters per second, which is less than that graph demonstrates, but that graph demonstrates is the average across the river rather than what actually the river can flow at on certain parts of the cross section. The divers did have flow rate meters on site, so they could work safely depending on what that meter would tell them. Okay. So you saw some photographs how lovely it looked in summer with calm water. This was the reality of delivering the scheme. Incredibly high water, incredible, difficult working conditions with rain and wind as well added to that. Actually meant that we had the work suspended on several occasions during. We delivered the initial part of the scheme in a 9-day blockade in February 21. Unfortunately, we didn't get all the work complete because the work was suspended so many times. You've got to appreciate that we were working 24 hours a day, and during the hours of darkness and during periods of heavy rain, high winds and high tidal conditions, it simply wasn't safe to work. So we had to suspend the work several times during the first 9-day blockade, but we did have backup blockades where we came back in and finished the scheme. And then there's another photograph. The photograph on the left is the access road from the east. You can see that the whole access road is underwater. It was the same on the west side. What was even worse on the west side, the access road on the west side was just underwater constantly. On the east side, it went up and down a bit, so we could use it during periods. It wasn't such a problem for the likes of the divers who could walk down the access road. The photograph on the right shows one of the pontoons that we worked from had become dislodged. Again, that was during a period of suspension when we couldn't work. Just back to planning the works. Obviously, we'd planned it in finite detail. Each activity was laid out in programs. Critical path was analysed to ensure that we had the right resource on site, the right skills on site, the right materials on site for the different activities. what the program couldn't account for, or we didn't correctly account for, was those extreme weather conditions. I mentioned before that the different activities on site required specialist workers. So we had diving operations, either fully submerged or partially submerged divers. We brought specialist contractors to deliver this work. So you had the fully submerged guys working underwater with full breathing apparatus, helmets on, pipelines for the breathing. And then you had the partially submerged activities. Just got a couple of videos just to show you how difficult it was. Later on in the presentation, I've got some videos of those different activities. You can see how hard it was. When we realised we couldn't use scaffolding, we obviously brought mobile barges and pontoons in. So we had a large pontoon at the back of that photograph, which had an arm on it, which was able to do lifting operations. It was a good working platform. Those two piles sticking up the back of that barge, they drop down to stabilise it. They drop into the riverbed to keep it firm in position. The orange pontoon below the barge is a cellular plastic pontoon. We use lots of those on the site, very mobile, fairly stable. They can be moved around during the different work activities, and you can see there was two orange boats which we used to ferry staff around, and they also pushed the barges and the pontoons into position as well. I think we had two of the orange boats and a larger more like a speedboat, which would push the barge around. Some other photographs which enable you to see us working from those pontoons and barges. So we generally use the cellular pontoons to put scaffolding on, materials on, and men from. The larger barge we used as a diving platform. You see the divers there on the right of that photograph on the right. They could put all their equipment and hoses and airlines and breathing equipment on there. Off track, we used road rail vehicles, 30-ton giga cranes with lifting beams. These vehicles would deliver timber elements, mainly edge beams from the railway side. They work over the handrail to drop elements of the structure in. You can see some edge beams on the trailer in front of the giga crane there. There's the crane in operation. The larger photograph shows the giga crane dropping in edge beams. So those are edge beams going in under the deck. They sit on top of the corbels, which go over the top of the crossheads. In the background, you can see the barge working with the mechanical arm, doing various lifting operations, and the divers working from it as well. We had two giga cranes working simultaneously on the site, accessing from either end. Just a point to note that those gentlemen working on the deck, whilst we haven't got any edge protection, they were tethered to a safety line. You can just see the safety line was strapped to the track there. So it was a difficult working system, but it was safe, and we tried to minimise that as much as possible. I mentioned before that I've got a couple of little videos to show you. There's a little video here of the partially submerged type of works that we carried out. So I'll just play that video, and you can see we're changing some piles there, splicing them to the piles that are already in the riverbed. So I'll just play that video. So they're excavating the area around the splice, because the splice position was just above the water line. and that was recognised as an area where decay can occur. So we actually repositioned the splice further down under the water and in the riverbed, and that will enable us, enable it to last longer and be more resilient to rot and decay. There's one of the boats working very and about materials. And that's the eastern side. Okay, the next video is of a diver underwater inspecting one of the splices. The splice in the pile is where the old timber in the riverbed meets the new timber. These had to be properly inspected and worked on. The divers working underwater. My hats are off to those gentlemen. Incredibly difficult conditions. Got a video there. Footage of a splice under the water from one of the divers. As you can see, it's very dark and cold down there. The divers were only allowed to work 2 hours on, 2 hours off, so they're only allowed to be submerged underwater for 2 hours. Very cold in the water, of course. They obviously have to rest after 2 hours, even though the airlines do have warm air pumped into the dry suits. They're still, it's very cold down there, so 2 hours on, 2 hours off. So they have to work in shifts. So we had during the works, due to parts of the work being suspended for several hours at a time during the real weather conditions, when weather conditions really deteriorated. That meant we actually had to get more diving crews in to try and catch up with some of the work we left, that we lost. So we ended up with 2 diving contractors on site to get the works done in the first 9-day blockade. This is a photograph of the jacking system, the maybe jacking system. That's under the main beams of the structure. So it was jacked up off those props to enable us to change that crosshead. You can see the new crosshead with the 8 on the end sits on top of those piles. That's trestle number 4. So that crosshead was changed, use a combination of giga railers above to drop take the old crosshead out and drop the new crosshead in. You can see that some of the elements it marries up with are in okay condition. So you've got the piles are okay and the diagonals are okay there, but you can see the corbel that was replaced afterwards. You can see the corbel's in very poor condition there. Talked about the handrail previously. The handrail was replaced in its entirety. We replaced it with an FRP system from Easy Clamp, nice and light. This material went in, finished the job off really well actually. It made it look like a finished job for sure. A little bit more about the piles I described before, that we had to drop the splices down to make sure they were actually underground or under the water to stop them decaying. We used, depending on which trestle we were working on at any time, obviously if it was nearer the riverbank we could work partially submerged or excavate around it and dewater, pump and sump to dewater that to give us access to those. A little bit harder underwater where the piles were spliced and the divers delivered those elements of the work. We used various lifting arms for some of the piles, but other piles were moved out and replaced using block and tackle. You can see the block and tackle there. It's chains and pulleys that enable us to secure and lift the elements out and replace them. During the 9-day blockade, we ran out of time to replace all the elements, and because we'd kind of had a go at different parts of the structure all over the place, we didn't start at one end and go all the way through to the other end, because that wasn't the most efficient way of doing it. We kind of worked on many of the trestles simultaneously. We had a bit of a headache when we were approaching the end of the blockade. You know, we had 2 weekends and a week to deliver all the works. You know, many times during that period we had works suspended. Now we were heading towards opening the line for trains running. I had to sign the structure off to say it was safe and fit for trains to run over it. And we had a bit of a task of establishing which pieces of work we had done, which pieces of work we hadn't done, which pieces of work were absolutely critical to enable us to run trains over it. So I spent many days during the hours of darkness and in the light, bobbing around on a boat, trying to establish which bits of the structure we'd completed and which bits were critical and which weren't, and that included the straps and the bolts. And it was quite a stressful time on the weekend before we reopened on the Monday morning to get out there and establish all the bits which had been done. And there's some of the engineers' notes that we took during that. Cass Hayward were on site, the consulting engineers, and they helped with identifying these bits which had to be done, which we could leave for another blockade to get it open. And we did. We opened on time on the Monday morning without any issue, but we obviously had to come back to finish the scheme off. Originally planned for a 9-day blockade in February. Reality is that we needed 2 more blockades. So we came back in March for another blockade to do some more work. And then in September, we finished the scheme off and did all the snagging, all the little bits which we hadn't been able to do during the first 2 blockades. The line was blocked anyway because of the Barmouth Viaduct scheme had started by this time. And I think they closed the railway for 3 or 4 months to deliver the Barmouth work. So we were able to get on the back of that, and that helped us a lot. But yeah, it was very challenging environment to work. And there we have it. There's the finished product on a lovely day in September, and the sun came out and made it look like it was really easy. That's the new handrail, and you can see there, and the different elements have been changed. Nice environment. Little video here that Easy Clamp did for us. A nice little video that a bit of some drone footage showing the viaduct. Okay. How are we doing for time, Dave? Are we okay?
It's 15 minutes or 14 minutes left till 2 o'clock, if that's okay.
Yeah, sure. As part of planning the work and programming the work and sort of stakeholder management, we got some animations done of delivering the scheme. We used a company called Robotics, who took the design drawings from us and the program, and they combined that into a bit of an animation to show the whole scheme, just to show how it fitted together. You know, sort of clash detection from a sort of sequencing point of view. You know, getting materials on site, getting men on site for the right activities. So I'll just show you a little bit of this quickly. I won't show you the whole thing because it's 8 minutes long, but I'll just give you a quick demonstration of what Robotics did for us. So that obviously, a bit like my presentation, describes the site in Porthmadog, where we are located geographically in North Wales. The location of the viaduct itself and the access and the flooding that we were going to get, and then compound where materials were stored as well on the east side. And then we zoom in on the construction area itself. So yeah, we had this animation done showing the guys working from the platforms and changing the different elements of the structure. So we ran that through the whole program. You can see the divers in there and the block and tackle, replacing the different bits, the splice in the piles, and you know, we ran that right through the structure. It's quite long-winded in some respects, but obviously very useful as well. We had elements of it where the structure would be working as well. The road rail vehicles on the crane as well. So you see that's a different pontoon with a different attachment. So we were able to sort of model and animate every element of the construction. So
Could you drop that in the chat, Carl? Is that possible? Or share that link to that animation?
It's a pretty big file, I think, Dave.
Is there a link to it or not?
I'll double check.
Yeah.
Well, it's going to be, if it's record, I think most of it's on YouTube, so we should be able to yeah, we'll sort something out. Shall I pause it there for questions then?
If you want, you can keep it running if you want, Carl, and we'll just take some questions as it's going. So yeah, first of all, Carl, well, fantastic presentation, really obviously challenging site. I'm going to squeeze a little question for myself before I raise any others. Just on the scoping side, you said that was done by others.
Yeah.
Did you find any elements that you need to replace as you uncovered it, or was it basically as the spec provided?
It was pretty much as the spec, Dave. We obviously we had plenty of access in advance of the job. I think we inherited the scheme at AIP, so we were scoped to deliver the Form B detailed design and the AFCs. So we obviously had opportunities to work with the designers, Cass Haywood, to develop that. So, you know, we visited sites several times, did additional surveys just to make sure that the original scope was something like what we had to go out and deliver. So, yeah, we didn't really find any, you know, elements, any additional elements. And it would have been, there's nothing we could have done about it anyway, Dave, that, you know, the timbers came from Guyana.
Right.
I forgot to say, you know, during COVID, we were in full lockdown when we delivered this scheme. Oh. You know, the timbers came on a boat from Guyana in the middle of lockdown. It was all a bit, you know, we were all very anxious, but had a bit of luck and some good planning, which enabled us to do the job.
So maybe connected with that, Paul, there's a couple of questions I'll probably bring together. Paul Evans and Patrick Dickinson. It was about just, was there any environmentally friendly alternatives to the hardwoods, or could FFUs been used instead of the timber? Was there any analysis on that done?
There wasn't any analysis done on that, but yeah, I'm aware of this and have been kind of frustrated over the last few years working on timber trestle bridges and way beams in particular. You know, we're kind of told by certain people in Network Rail that it's business as usual. Well, I found very few people to talk to find out who's doing it as business as usual. But yeah, it's a really good point, and yeah, I find it a bit frustrating that we're not using more composite materials for, you know, replacing way beams and probably parts of the structure.
All right, so that's interesting to know. Andrew Craven asked a question about why the works was done in February when the daylight is short and the weather is poor, etc.
I know it's you know, hindsight's a wonderful thing, isn't it? I think obviously it suited the train operators to have it done in the winter when there's less people travelling. Summer, you know, summer is a time when, you know, the line becomes very busy. People want to travel on it to access their holidays. You know, you've got what used to be I think Pontins at Pwllheli, right on the end of the line. You know, during the summer, it was seemed as, you know, we're not doing this because we've got to keep trains running. So can you please do the job in winter? So yeah, not a stupid question.
Yeah, and that brings on to the next question from Ben Lee. What about the operation arrangement for the trains when the work was carried out?
Yeah, unfortunately, people had to get on buses, and not really a nice place to get a bus, really. North Wales, certainly that part of North Wales, not brilliant to get a bus. But yeah, all the services during the blockades were replaced with bus services, coach services, and towards the September blockade, that was during the Barmouth blockade. So yeah, there were different sections where the trains could run, but there weren't any trains running north of Dovey Junction during our, which was only a 9-day blockade. So yeah.
Okay. If anyone would like to raise another question, please, I don't know, put your hand up through the teams. If not, I'll. Mr. Higgins, have you got a question?
Go on, Rob.
Hey, Carl.
Hi, Rob.
Yeah. Was there any track monitoring or structure monitoring in place during the works, and also with replacing certain sort of like structural elements and members? Were there any deflection calculations undertaken?
Yes, there was, Rob. I forgot to pick up on that point. Yeah, we got ProTech in from South Wales. ProTech, and the original survey was done by PBH. So they did the baseline survey for us, and then ProTech came in and did the sort of track monitoring and track hand back at the end of the shifts. Yeah, we kept a very close eye on that to make sure that the structure went back to its original position. We only jacked it up about 50 mil in the end, so it wasn't a significant jack. I think we put targets on top of the structure as well. So we put the reflectorless targets. We put control, put a station on either side of the structure on the embankments. So we had a baseline to work from, and then we monitored using targets. Yeah. Sorry, I missed that out of the presentation, didn't I?
So pretty much after each shift.
Yes.
You'd take a base. Yeah.
Yeah.
I take it can I do a follow-up question very quickly? I take it
one.
with being bullhead, it was jointed and fish plated.
It was, yeah.
Did you do a joint closure?
Yes, we did.
Survey? Did it affect any of the joints or the fish plates or the bolts?
Yeah, we did. Dan Rivers and his dad from Protect Rail did a joint survey for us, check the gaps. But CRT management was done as well. Yeah.
Thank you, Rob.
And no impact from the 50 mil lift, I take it.
No.
Excellent. Cheers, Carl.
Cheers,
Dave.
Yeah. Mark Stowell, have you got a question?
I do. Hello, Carl.
Hi, Mark. You all right?
I'm good, thanks. Hope things are good there. Hey, just a quick question on maintainability. Did you make any improvements from a maintainability viewpoint, such as reducing maintenance? Were some of from that underwater video? Were they stainless steel
Yes.
members, the elements you're putting in?
Yeah. So from the maintainability perspective, obviously using Green Heart, incredibly resilient material. It doesn't rot like the softwood, which had been elements had been replaced by British Rail, probably using softwood. So from that perspective, yeah, the hardwood lasts longer, is more resilient to rot. And yeah, you're right, the stainless steel straps and clamps all over the structure as well. I mean, it was very much a like for like replacement, but obviously the materials were definitely better than what had been done in the past.
Yeah. Okay. Thank you, Carl.
Yeah, very last one from Adam Owens. Just put a question in the chat there. Given you said that the P-way components were from 1930s, was there no appetite for P-way renewal while the blockade was in place?
Not during our blockade. I believe there was supposed to be a phase 2 this year where they would have replaced the way beams. I don't know whether the track system, because the way beams certainly weren't from the 1930s, because the transoms and the tie bars were probably only about 10, 15 years old from my observations. Yeah, it does seem strange them putting the old materials back, doesn't it? I know there was some new sections of track further to the east, but yeah, there's a lot of bullhead on the North Wales on that part of the Cambrian Railway. I guess it's one of the last railways where they're still running bullhead under what's effectively a main line with a regular train service. I guess the maintainer's happy with it, or keeps getting his renewal deferred. Yeah, it was under the structures framework that we were doing this, so yeah, no, we didn't touch the track.
Okay, all right. Well, again, thank you, Carl, for going to present today. You know, really interesting presentation. And are you the go-to person for wooden trestle bridges now? Is that what
I
you're
wouldn't
saying?
say that, but I'm happy to. I'm happy. Obviously, Alan Griffiths, the contractors, did Barmouth Viaduct at kind of the same time. That's a much bigger scheme, bigger scale. So some interesting stuff going on there. But yeah, I'm really pleased that I was able to sort of relive part of my early railway career when I used to detail timber trestle bridges like this.
Oh, wow.
To be able to sort of go out there and deliver one was an honour, really.
Brilliant. Okay, well, I don't know if people can unmute or give virtual applauses or whatever we do these days. Thank you very much, Carl. I'll clap away with a
Thanks, guys.
audible one. I'll put the next section meeting is due to be on lessons learned from Carmont next month. We'll advertise that accordingly. Thanks again for attending, and feel free to do so in the future. Okay, I'll close the meeting now. Thank you very much. Cheers,
Thanks, guys.